More than 21 centuries ago, a mechanism of fabulous ingenuity was created in Greece, a machine capable of indicating exactly how the sky would look for decades to come, the position of the sun and moon, lunar phases, and even eclipses. But this incredible invention would be drowned in the sea and its secret forgotten for 2,000 years. The Roman ships traveling from Asia Minor to Italy passed between the Peloponnesus and Crete. The small island of Antikythera sits right in the middle of this maritime corridor. Its craggy, rugged coast presented a real threat to passing ships, which could be dashed against the unforgiving rocks in a storm. This is precisely what happened around 70 BCE to the ship filled with treasures we now call the Antikythera wreck. In 1900, fishermen diving for sponges spied a bronze hand on the seafloor. They told the Greek authorities, who, the next winter, searched the Antikythera coast around the shipwreck. Half concealed in the seabed, they found more than 200 amphorae, some of them intact. Nearby were the usual objects of a ship's crew, such as oil lamps. There were also finely worked vases. The more they searched, the more exceptional objects came to light. In fact, this Roman boat, perhaps on its way from Rhodes or the coast of Asia Minor in what is today Turkey, had been carrying some of the most prized works of art of its day. The bronze hand proved to belong to a 5th century BCE Greek sculpture of a philosopher, whose head and some other limbs were later found. Another major discovery was a bronze Ephebi, a Hellenistic masterpiece sculpted around 340 BCE. Half submerged in the seabed, more statues were preserved from corrosion by the sand and sediment. They lift the veil slightly on the genius which created them from stone. Amongst these sublime objects, the divers found an intriguing bronze item, about 20 centimeters high, which began to disintegrate as soon as it was removed from the water. From the first, scientists realized that this was a mechanism for astronomical data. Scrupulously preserved at the National Archaeological Museum of Athens with the other objects from the wreck, the mechanism aroused the curiosity of many researchers. It was only in the 21st century that modern tools for scanning could penetrate the corrosion to reveal in 3 dimensions the interior of the machine. This showed a set of interlocking gears of astounding ingenuity. High-resolution photographs using different exposures brought to light inscriptions on the sides of the machine which appeared to be part of an instruction manual. Scientists compared the numbers inscribed in the text to the number of teeth in the gears and their arrangement, and applied these to the known astronomical cycles of antiquity. Thus, a reliable reconstitution has been made.
All the clues point to the same date, including the metallurgical analysis and especially the text analysis. The form of the letters is typical of the period, and the vocabulary used is found on all the other texts of the same period. Given the extensive information we have, a reliable reconstitution can be made.
Housed in a rectangular frame, the machine shows data on both sides. In front is the larger dial, showing the 365 days of the year according to the Egyptian solar calendar. Inside, a second circle shows the 12 signs of the zodiac. By turning a handle, one could position the 2 hands to indicate, for each day of the year, the exact position of the sun and moon, and a small sphere indicating the phase of the moon. In order to guarantee its exactitude, whatever the day or year chosen, a dial on the back of the mechanism shows the metonic cycle, which reflects lunar and solar cycles over a period of 19 years, corresponding to 235 lunar months. Above this, another spiral dial indicates eclipses of the sun and moon. The handle was used to advance the pointer to determine when the next eclipse would occur in the Saros cycle. As these operations were connected by the interlocking gears, the actual date of the eclipse showed on the other dial. How did the Greeks manage to devise a mechanism to reflect such complex and irregular data as the lunar cycles? The question also intrigues today's specialists in fine watchmaking. Mathias Butte, Director of Research and Development at Hublot, decided to reproduce these ancient forgotten calculations and integrate them into a modern watch.
Je voulais pas être comme un pilleur de tombes qui vient voler une idée.
I didn't want to be like a tomb robber who comes to steal an idea which has existed for a long time, but rather like someone who approaches our forefathers with deep respect, whose goal is to recreate the antique object in a contemporary form. The original is about 20 centimeters high, and we have been able to recreate a 30mm movement which can easily be worn on a wrist. This Antikythera mechanism includes ingenious features which are not found in modern watchmaking.
Several writers in antiquity, including Cicero, mention the existence of similar machines, but the Antikythera mechanism is the only one which has been recovered. It was recently discovered that it also indicates which cities would host future Olympic Games held every 4 years. It is also believed to trace the path of certain planets, including Venus. Who invented this machine? For whom and for what purpose? We still have no answers to these questions, but research continues, constantly uncovering further mechanical and mathematical subtleties, adjusting our perception of the ancient world and its technology.